Hello everyone, welcome to Rao's IAS Focus Weekly. Today on 23rd of January 2025, we'll be discussing the latest developments in the subjects of science and technology from the date of 16th of January 2025 till 22nd of January 2025, and the topics that I'm going to discuss are listed here. We'll start with our discussion on the DRDO Scramjet engine. It has been an incredible achievement of India's defense sector as well as the overall missile technology development. Then we'll talk about the space docking experiment performed by ISRO. I have previously also mentioned about it when we were discussing the PSLV C-60 mission. Then we'll talk about the recently inducted INS Surat, INS Nilgiri, INS Vaghsheer that has been commissioned by the Indian Navy. Then we'll talk about the recently discovered or believed to be discovered semi-Dirac fermion particle. It is a topic related to quantum physics, standard atomic model. So we'll talk about that also here. Then we'll discuss the third launch pad that is now been approved. The cabinet has given an approval to set up the third launch pad for ISRO's space satellite launch vehicle launching at Sriharikota. Then we'll talk about the new definition for obesity. Right, obesity is a big problem in the entire world, but especially among the urban Indians. And now there has been a new definition for obesity. It is not just related to body fat, but other figures also. Right, we'll see that. Then we'll talk about what is this concept of synthetic antivenom and the rDNA technology used to develop new kinds of snake antivenom or antidotes. Then we'll also talk about the cervical cancer vaccine, or famously known as the HPV vaccine, this which have been recommended to be inculcated under the National Immunization Program. So these are going to be the topics that we'll discuss in today's class. And let's start with the first one, right? So the first topic of discussion is the Scramjet engine developed by DRDO. Now, this has been very widely discussed in the class as well, but this becomes an important discovery or important innovation from DRDO because this paves way to develop hypersonic missile technology in India, right? Now, we already know that when it comes to missile technology, what matters is how quickly you can respond, how quick your defense military arsenals are, how quick you can attack, and that gives a natural advantage to any country which can develop such capabilities. Now, when it comes to missile technology, we normally identify missiles in terms of their speed. So, we often consider missiles as subsonic. So subsonic missiles are technically those missiles which are capable of flying at a speed less than the speed of sound. We often use an expression called Mach number, but it's not required to talk about Mach number here. So you just can remember that subsonic missiles are those missiles that are capable of flying at a speed less than the speed of sound. We consider the speed of sound equal to close to 332 meters per second, right? So which is the speed at 0 degrees Celsius, by the way. So subsonic is the speed when an object is able to fly at a speed less than the speed of sound, which is 332 meters per second. Then guys, the next speed that we have is called sonic speed. Sonic speed is the speed where an object can fly at a speed equal to the speed of sound. And then we have something called supersonic speed. What is supersonic? Supersonic is the speed where an object can touch a speed faster than the speed of sound. So when an object can fly faster than the speed of sound, we often consider it as supersonic, right? So when it can fly less than the speed of sound, subsonic. Where it can fly close to the speed of sound, sonic. And when it can fly faster than the speed of sound, we call it supersonic. Then what is hypersonic, guys? Hypersonic basically is also the speed faster than the speed of sound, but it is by the multiple of 5. That means when an object is able to fly 5 times or more than the speed of sound, in that case we consider it as hypersonic speed. So hypersonic speed basically means when an object is capable of flying at a speed of 5 times or more than the speed of sound. Just imagine, guys, 5 times or more. That means if I am shouting towards you, a hypersonic missile can reach you 5 times faster than my voice. Right? So that's how fast a hypersonic missile can touch. Now guys, when you talk about speed, speed gives you a natural edge. Speed can give you a decisive edge at the time of a battlefield. So every country is trying to develop, if they want to claim themselves as a superpower or a regional power, in fact, or a regional power also, it is important that they end up developing fast or quick response attack systems. So already Russia, USA and China have been able to achieve this, and India has become the fourth country now to have successfully tested and indigenously developed engine technology that can help us reach hypersonic speed. So what is Scramjet, guys? Scramjet is basically an engine. It is basically an engine, or you can call it a propulsion technology. Propulsion basically means a system that propels that particular speed. So it is a propulsion system that is capable of touching hypersonic velocity. Now India is the fourth country to achieve this, and what is even more interesting about it, that India has been able to indigenously develop this entire engine technology. And we have recently conducted a ground test. Ground test basically means that we have not put it in a missile and taken a flight. We have basically tried to run this engine and see if all the parameters required to touch hypersonic speed are being demonstrated when the engine is being run on ground, right? So it is basically a kind of a test that is done in a closed facility, but India is the fourth country to even develop this, right? So we have developed an indigenous scramjet engine that is capable of propelling a missile up to hypersonic speed levels. I hope all of you guys are able to understand. Now, before I go ahead and talk about Scramjet of India, let's talk about what types of propulsion technologies are generally there in high speed or in high speed locomotives or in high speed warfare. So guys, we normally have three types of engines, right? The most popular engine is the jet engine. This is basically what the jet engine is, right? Now, and then we have another type of engine technology called ramjet. Let me use a different color here. Then we have something called ramjet, and then we have something called scramjet. So just to help you out with this third one is the C diagram is the scramjet principle. This is the ramjet, and this one is the simple jet engine, right? So all of us understand that we have fighter aircrafts which happens to run at a high speed. They're also capable of touching supersonic speeds. We also have other missile systems which are capable of reaching supersonic levels, subsonic, supersonic levels, and at the same time we also have now engine technology that can propel us to touch hypersonic levels. So all these three types of speeds, subsonic, supersonic and hypersonic, they happen to use different types of propulsion system. The most popular propulsion system, or the most common one, is the jet propulsion system, which is normally equipped in your jet aircrafts and also in some old traditional missile systems. Now in the case of any random engine, even if you consider an engine of a car, the principle is same. The principle happens to be the same. We basically have an intake where there is an inlet. Inlet is the place. Inlet is basically that particular component from where the air and fuel mixture enters, and then there is an outlet. There is a combustion chamber. There is a combustion taking place of that inlet, and then there is an outlet. So basically, the principle is same. There has to be some inlet, and then there would be a combustion chamber, and then there is going to be an outlet, right? As simple as this. In case of a jet engine, a missile ramjet engine and a scramjet engine, the things again remains the same. Basically, if you look at their design, the design is very simple. In all these three designs, the air intake happens from here. From here, the air goes in. As you can see here also, the air goes in from here, right? Then we have a combustion chamber here. So you can see it has been shown with red color. The combustion chamber of the ramjet engine, this is the combustion chamber of the scramjet engine, and then we have the combustion unit of the jet engine. And then whatever energy has been produced, it is going to be thrown out in a form of a thrust. Thrust is basically, force acting in a single direction. So it is going to be released in a form of a thrust, and that thrust is going to be propelling this entire rocket this entire aeroplane or missile in the direction opposite of the thrust, right? So thrust is basically when the entire pressure is acting at a single point, at a single direction, right? We call it thrust. So this is basically the base principle, right? In the case of the jet engine, I am considering the standards of UPSC, so we don't have to dive very deep and understand what exactly is the injector made up of, where how the turbines are going to function, right? All these things we don't have to see. We just have to look at the superficial understanding of the topic is enough. So when you talk about the jet engines, in the case of jet engines, we have the air inlet, and then we have the combustion chamber, and then we have got the air outlet, right? So the exhaust we call it, right? The air outlet. So in the case of jet engines, what happens? The air may be moving in. Even if it is not moving, it can still suck in air because it has a lot of turbines. These turbines can behave like a sucking unit which can suck a lot of air. Even when the aircraft is not flying, it can do that. And then the combustion chamber will further propel the air to move out. And then the thrust is going to be produced, which will propel this particular aircraft or the rocket to go ahead. Right? This is what happens in the case of a normal jet engine. In the case of ramjet and scramjet engine, if you look at it carefully, you will notice that there are hardly any moving parts here. The ramjet and scramjet engine, they happen to be very simply designed based on a simple idea that if you eliminate all the moving parts, then how we can propel all these missiles to go faster. So in the case of jet engine, there happens to be a lot of moving parts. There happens to be, a series of turbines, turbine blades. There has to be an entire combustion chamber, right? All these are a lot of moving parts are being used in a jet engine. Whereas in a ramjet or a scramjet engine, there is a minimalistic design. We don't have any moving parts here, right? So what is the concept here? What logic we are using here? So in the case of ramjet or scramjet, principally they both are same. What we basically have is, we basically have an air inlet chamber. We have got an air inlet chamber, and as the air moves in, so let's suppose if an object is already moving, the air that will be moving in, let's say for example, if there is an aircraft flying at a speed of 100 kilometers per hour. Suppose if there is an aircraft flying at a speed of 100 kilometers per hour, we can assume if the aircraft is moving, or we can also say that the aircraft is stationary and the air that is moving into the aircraft, this air is at 100 kilometers per hour. I hope you understand relative velocity here. So imagine if I am moving at a speed of 100 kilometers per hour, I can say that either my speed is 100 kilometers per hour, or I can see it relatively, where I'll keep myself stationary and feel as if the air is hitting me at a speed of 100 kilometers per hour. The impact is going to be the same, right? So when it comes to this entire concept, that imagine if the air is hitting us, considering our position as stationary, and imagine if the air is hitting us at a speed of 100 kilometers per hour, then what will happen? All this air is going to be moved, or all this air will be moving into the inlet of the ramjet or the scramjet engine. Now when this air is moving in, what we'll do, we'll try to compress this air. You can see the design seems to be very standard, right? The design seems to be very standardized here, right? Very minimalistic design. So as the air moves in, as the air goes into these chambers, you can see that the entire air has been compressed, right? The entire air has been compressed with the help of this entire design. The design has been put in such a way so that the air that moves in, it naturally gets compressed, right? And now as the air has got compressed, what we have next, in the case of ramjet engine, we have got an expansion chamber. You can see that once the air has got compressed, and then it has got expanded. Now as the air has got expanded, what happens here, as the air gets expanded, the speed of the air starts decreasing, right? The speed of the air decreases, and as the speed of the air decreases, then there is a combustion taking place, and then this combustion further propels the air to move out at a high speed. I'll repeat this part. So when it comes to the working of the ramjet and the scramjet engine, they both have very minimalistic design. They both have function in a simple way that they don't use any moving parts. So basically these are the kind of engines that are functional in those missiles or rocket systems which are already in motion. You can't start a missile with a ramjet engine. The engines, both scramjet and ramjet, requires the speed of the vehicle already to be very high. Only then these engines can further propel, right? So when you look at ramjet and scramjet engine, they do not have the capability of pushing a missile from 0 to supersonic speed or 0 to hypersonic. The object or the missile should already be in motion, and when it is already traveling in motion, only then it can propel the object or the missile or the spacecraft or whatever vehicle we are using to further go ahead in speed, touch supersonic and even hypersonic levels. So they both work by the same principle, that the object should already be in motion. And what is the difference between the two? The difference is very simple. The difference lies, or it is hidden in the design itself. So basically, if the ramjet and scramjet engines are functioning, the incoming air should already be at a high speed. Let's assume that the incoming air itself is at supersonic levels. The speed faster than the speed of sound. It is already at supersonic levels. Now, when this air is going to be further compressed, in the case of both ramjet and scramjet, the air is being further compressed. But in the case of ramjet engine, there is a small unit where the air gets decompressed, and when it gets decompressed at this particular point, the air reduces its speed from supersonic to subsonic levels. Supersonic to subsonic levels. Here the speed gets reduced from supersonic to subsonic levels, and then the propulsion system gets activated, the combustion happens, and the combustion pushes this combustion further pushes the air at a high speed moving out from the exhaust nozzle. So this exhaust nozzle is going to push the object at a high speed, supersonic speed, after the combustion chamber has functioned here. Actually, why this speed has to be reduced? Think about it, guys. If I have a candle in front of me and I lighten this up, now the flame is very sensitive. If I try to blow this candle away, I'll just use the air throw from my mouth, and the candle may be blown away, right? I hope all of you understand whenever you try to blow away the candles, right? So it is very obvious that if you want to run combustion, if you want to burn any fuel, if you feel like burning any fuel, it's very obvious that the fuel, in order to burn, you cannot have a very strong inflow of air, because it's very likely that the air that is moving in, it's never going to allow the flame to be produced. It's never going to allow the combustion to happen, the fuel to burn. It's never going to allow. It is like blowing away the candles. The moment when you lighten the candle, you blow it away. So it is that kind of a situation. So in the case of ramjet engine, when the air scoops in to the inlet, we have to slow down the air so that the combustion can really take place. And as the combustion happens, the energy released from the combustion is going to propel the exhaust nozzle to further accelerate the missile. Whereas in the case of, in the problem with ramjet engine is that because the air that is moving in is made to slow down, that's why the maximum speed that a ramjet engine can propel is never going to cross supersonic levels. The maximum speed that it may touch is never going to go beyond supersonic levels. But when you compare it with scramjet engine, in the design of the scramjet engine, you can notice that there is no mechanism of reducing the speed of the incoming air. The air that is moving in, it is pressurized so much through this design that the air is moving naturally at a very high speed, and in that high speed moving air, we perform the combustion of the fuel, and this combustion further propels the air to let this engine push the missiles even way higher than supersonic speed. So only with the help of scramjet engine technology, we may be able to push the incoming air to propel and cross the hypersonic speed barrier as well, going at a speed 5 times higher than the speed of sound. And this is the technology which the DRDO scientists have recently tested. Mind my words, guys, ISRO scientists have already tested the scramjet technology, which was a slightly different design, but they have already tested their engine technology, and they are expected to use it for satellite launch vehicles. DRDO has used it in a much more simplistic and minimalistic design, and it is expected to be used in our hypersonic missile technology. I hope you guys have been able to understand. Now let us see some of its feature. So this particular engine is also referred as an air propulsion or an air breathing engine. See, basically, why do we call it the air breathing engine? This is the commonality between ISRO scramjet and the DRDO scramjet. See, it is very obvious that whenever you burn fuel, in order to burn fuel, we need oxygen. Oxygen is a prerequisite to perform combustion, right? So in order to have any combustion performed, we need to have oxygen supply. Consistent oxygen supply has to be there, and in fact higher oxygen supply will propel even greater energy output, because the burning efficiency is going to be even better. So when it comes to a normal jet engine, you may mix oxidizers with the fuel, and those oxidizers will propel the burning of the fuel. But in the case of scramjet engine, we do not add oxygen in the starting or in the launch of the missile. What we do instead, we allow the oxygen from the atmosphere to move into the engine, and you will use the same oxygen that is already there in the atmosphere, will use the same oxygen that is there in the atmosphere to propel the entire combustion process. So in this way, the overall launching weight, the overall takeoff weight of the missile can be reduced, because we do not have to carry separate oxygen. The missile can itself, the engine can itself breathe in oxygen while it is propelling all around the atmosphere. So this makes this technology even better, because otherwise in previously for ramjet and even for jet engines, we may have to carry oxygen if you are trying to propel it out of the Earth's atmosphere or at touch a speed which is very high. So this makes the scramjet engine even better. So it is famously called the air breathing propulsion system, because it is acquiring oxygen from the atmosphere itself as it moves, right? Then it does not contain any moving parts. Like I said already, it does not contain any compressor, does not contain any turbine, none of these types are there. It's a very simple minimalistic design. Then earlier ISRO has already, like I said, already tested the scramjet engine by using liquid hydrogen, as the fuel, and liquid oxygen as the oxidizer. But remember, this liquid oxygen is not carried at the time of takeoff. It is actually absorbed from the atmosphere during the journey of this particular engine. I hope all of you understand. So combustion occurs at the so this is what I said. So for scramjet engine to function, we want the incoming air to enter at supersonic speed, so that we allow the combustion to happen at supersonic speed, so that the thrust can propel it even ahead of that and touch hypersonic speed levels. So this is basically what is the basic function of the scramjet engine. Now it is highly likely that UPSC can ask straightforward features of scramjet engine, or if they want to make it a little more complicated, they can even ask you a comparison between scramjet and ramjet engine. So I request you to keep all this conversation that I had with you, keep it handy, keep it written in your notebook. It is always advisable to keep a notebook, when you are watching these videos, and keep making notes, right? So the conversation that I keep having like this, it will help you, and even when you read it further from the Rouse Compass website, you'll be able to understand the things even better, because that has been more elaborated from here, right? I hope all of you have understood the concept. So you can expect questions where they can ask you to compare ramjet and scramjet technology. You can also be asked questions straight away related to the features of scramjet technology, what makes it unique, right? And you can also be asked questions related to which missile system is being developed in India that is capable of having hypersonic or supersonic speed levels, right? So this is something that you can expect. Now this is our hypersonic technology demonstration vehicle. It is a prototype developed by DRDO, and this prototype has successfully been tested, right? You can see this another testing prototype here, which is a sounding rocket having the hypersonic technology demonstration vehicle, where India has successfully tested its scramjet engine. I hope all of you guys are able to understand. Now moving on from here, let's talk about the second achievement of ISRO here. After scramjet, let's talk about second achievement of ISRO. It is SpaDex, or the space docking experiment, right? So India again has become the fourth country in the world, the fourth country in the world to have successfully performed a space docking experiment, right? Now what exactly is space docking? We have talked about this even previously as well, when we are talking about PSLV C60. It was the latest mission, or you can say the last mission of 2024 and the first mission of 2025 for ISRO. And this mission has brought India another success or another feather in the cap of ISRO, where India has become the fourth country to successfully perform space docking. Now, what exactly is space docking? I have told you previously as well. Again, I'll repeat. So, space docking simply means maneuvering two different vehicles in space and connecting them into a proper physical contact with each other so that they can transfer material, they can transfer people, they can transfer and become a single unit, right? So that's technically what is called docking. We often use the word docking for ships around the harbor. We often use docking for multiple types of transportation system. This is basically a type of docking that is performed in space, right? The first astronaut to perform space docking was Neil Armstrong himself, right? He was the first person to actually guide a successful space docking, and USA was the first country to achieve this. It was in 1966 where the Americans became the first country to do this. So these are the two satellites that we had put under the space docking experiment. We have named them as simple SpaDex 1, SpaDex A, SpaDex B. Here one of the satellite happens to be the chaser and the other satellite happens to be the target. So one satellite is the target and the other satellite is going to chase the target and eventually have a physical contact, a complete physical contact with it. And here you can see the images of the locking of the two satellites together. This particular image was also captured by another satellite of ISRO that was looking and monitoring both the SpaDex satellites, and this locking mechanism has been observed here where we have been able to successfully lock them. Mind my words, these two satellites are going to be there for 2 years, and ISRO will also perform an undocking experiment, because I hope you understand in future when you talk about launching future human space missions, when you talk about setting up an entire space station for India, when you talk about setting up large scale space hardware, it is obvious that our launch vehicles will go to space. They'll be docking with the available space station, and then eventually they will also have to undock so that they can safely move out and eventually come back to Earth. So if these things are going to be realized, if these things are expected to become possible, then we also have to perform an undocking experiment where we can safely undock from each other, right? So this is what is the SpaDex experiment. Let's see some of the important pointers on SpaDex. So I have already told you that C60, it was PSLV C60, the 60th mission of the PSLV rocket that was launched on 30th December 2024. It was the 60th mission, and here India has put up two satellites called as SpaDex 1 and SpaDex 2, also known as SpaDex A and B, where one of the SpaDex is the chaser and the other one is the target, right? Now here guys, we often use two expressions as well, rendezvous and docking. Rendezvous basically means where you simply follow and try to manipulate yourself so that you come in line with the target satellite. So when you want to move yourself, align yourself as per the target satellite, we call it rendezvous. And once the rendezvous has been implemented successfully, then you simply have to make a physical contact, and that physical contact is called docking. So these two are the expressions which are commonly used here. So India is the fourth country to achieve this. So we can read this simply. The satellites were first positioned around 5 kilometers from each other. So we had first put these satellites 5 kilometers apart, and then they were periodically brought closer and closer, right? So the chaser was brought closer and closer to the target satellite, and then when it performed the rendezvous of the SpaDex 1, this was the chaser, to 3 meters. So it was brought close as 3 meters to the target satellite. And then once it was brought close to 3 meters, and then on 15th of January, ISRO successfully joined both the satellites together, and that event is called the docking event. At an orbit of around 475 kilometers above the Earth's surface. 475 kilometers is considered as lower Earth orbit. So this particular experiment was performed in the lower Earth orbit. And remember guys, this experiment is very important considering the future possibilities, because India has already planned, we have already planned that we want to have our own space station by 2035. We have already planned that we want to send a manned lunar mission Indians will be going to the moon by 2040, and we are already planning in the coming years, in the near future, our first human space flight. So if the human space flight becomes a success, what is the next possible thing to do? So we'll have to have a space station, and then we have to perform docking, around that space station, so that we can transport goods, we can transport people and such, right? So this becomes a very important landmark in our indigenous growth of space program. So ISRO, what this docking experiment, this docking system that they have developed, they are calling it BDS. That stands for Bharatiya Docking System. So it's an indigenously docking system developed by ISRO, and it is named as BDS, Bharatiya Docking System. Then if I compare it with the internationally available docking system, right now International Space Station is the most popular destination in space. So when astronauts, they go to space, they use the International Docking System Standard, IDSS. IDSS was the docking standard that was built, and it was formulated in the year 2010, and based on this IDSS, other spacecrafts or space program that will come up in future, they may also use the same standard, so that the old vehicles remain compatible to the new innovations, right, to the new space stations. So the BDS is somewhat similar to the IDSS. It is very much similar to the IDSS, but instead of using the 24 motors, so there are 24 motors used in the International Docking System Standard, BDS has used just two motors. That means it is a very simple design docking system. So it uses just two motors instead of using 27 motors of the IDSS. Now there are new sensors being used, so that's why accuracy is much higher. There are new sensors being used compared to the IDSS, which requires the laser rangefinder, which require rendezvous sensor. I hope you understand rendezvous sensor. And then we also have proximity and docking sensor. So these are different types of new sensors being used. We are also using a new processor, which is better than the IDSS, right? Which makes the navigation of these docking systems even more independent. In fact, the future missions are expected to have more and more independent and autonomous docking systems created, right? So we have created a new processor based on the satellite navigation system to navigate the two satellites so that they can dock. And in future, we want to have a system where we do not require satellite based navigation data, where the docking happens automatically, right? So this is one step in that direction, probably the first step in that direction. And then after this, I'm sorry, so this is what we have, and you guys can understand what is the relevance of having the space docking experiment mission like this. It is quite obvious that we need such missions considering the future of human space flights, right? Human space flights, that is our Gaganyaan mission. India is also planning our first lunar space flight, or by 2040, and it is already well acknowledged that by 2035 we may also have our Bharatiya Antariksh station, right? That will be India's space station, which is expected to be launched by 2035. So in order to achieve all these milestone in the area of space, it is important that we develop more capabilities of further docking experiments. So this is what we have under the ISRO space docking experiment. Now UPSC can straight away ask a question in the mains talking about India's SpaDex and a comparison of this docking experiment with the traditional international docking system standard. They can also ask questions related to how the Indian docking system was performed, right? They can also ask things related to the relevance or the significance of this achievement, what could be the future possibilities. All these kind of questions can be asked both in prelims and mains, right? So I've tried to cover up that part, and I think it is easily possible to write a 150-word answer with the discussion that we have just now had. I hope all of you have been able to understand. Now the next point is, let's talk about the next thing. So next is the recently commissioned ships, which is INS Surat, INS Nilgiri, and INS Vaghsheer. These are the three military hardwares that has been inducted with the Indian Navy. on 15th of January 2025, and this particular day has been significant because these three are, first of all, indigenously developed. They have been manufactured in India. Of course, one of them has technology transferred from France. We'll talk about it. But the greatest achievement of Indian Navy here is that it clearly shows the progress India has made in indigenously delivering to the requirements of the Indian Navy. Right? So let's talk about the three military hardwares. The first one is INS Nilgiri. Now, INS Nilgiri, it is a stealth frigate class ship. Right, INS Nilgiri, you can see the image here. This is INS Nilgiri. So the first point says, guys, it has been developed under Project 17A. It has been developed under the Project 17A, guys. Actually, the Project 17A is an initiative of Indian Navy where the objective was to build seven stealth frigates. What is a frigate? Frigate, see, normally when you classify naval ships, we normally classify naval ships in terms of their weight, right? Which is defined in terms of displacement of water based on Archimedes principle. So if I dip an object, if I submerged an object in water, you know that some water level will rise in as the water gets dipped. So Archimedes principle says that if an object is submerged or freely floating, whatever weight of the water it has displaced, it is equal to the weight of the object submerged in the water. So if an object is fully submerged in the water, you can compare the weight of the water displaced and the weight of the object, it should be same. If the object is partially submerged in water, you can take the weight of the displaced water and the weight of the part of the body that has been submerged, and that would be equal, right? So that is basically what is considered as weight of the ship. So if a ship, say, if while reading the specification of the ship, if you come across to an expression that this particular ship has 1,000 tons of displacement, that means this happens to be the weight of the ship. It will be the total amount of water that it's going to displace. So that will be equal to the weight of the ship when it is submerged underwater or partly submerged underwater, right? So that is called displacement. So normally when it comes to naval ships, we identify and classify ships on the basis of their own weight or the amount of water displaced by them. So some of the biggest ships are known as, some of the biggest ships that we have, they are called as cruisers. Cruisers are some of the largest ships, right? They happens to have a weight of more than 10,000 tons. They are some of the biggest battleships on the in international waters, right? India does not maintain cruisers because as they are big, they also lack in maneuverability, and India is still not using cruisers, right? Mostly it is used by Russia and USA. There was a time when UK also had a cruiser ship, but now even they don't. Then after cruisers, the next type of ships are called destroyers. Destroyers are somewhat smaller or nearly 2,000 tons smaller or lighter than cruisers. Destroyers are also good ships, guys. They can go to a very far off distance. They can touch blue waters. Blue waters are basically the international high seas. We normally define navy in terms of brown water and blue water. Brown water navies are those navies which are very capable in the territorial waters, in the vicinity of the of their territory. They are very strong in that case. But blue water navy is the one that can actually perform and execute an operation even on the high seas. So America going into Atlantic Ocean, deep into the Atlantic Ocean, America going into deep into Pacific Ocean, Indian Ocean, that shows the blue water capability of the country. India is also growing in blue water capabilities. We are still a perfectly recognized brown water navy. In our brown water capabilities, India is considered at par with that of other major countries like USA and even Russia, right? But when it comes to blue water capabilities, our capability of going very far off into the high seas and execute an operation, we are strong enough to execute an operation in the Indian Ocean, in the deep Indian Ocean. But when it comes to blue water capabilities in the deep Pacific and deep Atlantic, we have some ships which can go there. Some ships can execute an operation, but we of course require more and more support, right? So we are not full-fledgedly capable of reaching up to that extent, right? So, but in terms of brown water capabilities, we are fully capable, as at par with that of any other country. So destroyers are somewhat smaller ships than cruisers. Then after destroyers, we have got frigates. Frigates. So you can see it's a frigate class. So frigates are somewhat 2000 to 3000 tons smaller than a destroyer, and after frigates we have got even smaller ships called corvettes, right? So as the ship gets smaller and smaller, its capability also get more and more limited. So when it comes to Project 17A, Project 17A involved developing seven indigenous stealth frigates. Seven indigenous stealth frigates. Right? What is the meaning of the word stealth? Stealth का मतलब क्या है? So stealth basically is the capability where you can make your military hardware hidden from any surveillance technology. So guys, let's say for example, if I put a ship in the open seas, and it is very obvious that if the enemy has the capability of sophisticated radars, if they have sophisticated radars located in their around their shore, it's obvious that they may be able to intercept my ship, and at any moment they may attack, right? With stealth features, the ship may remain parked at that particular location, but the enemy would struggle in identifying the exact location. It would struggle to identify if there is an enemy ship. In that case, this set of technology that we put in, we call it stealth technology or stealth features. There are multiple ways of creating stealth features. You can either change the design, you can leave any flat surfaces, you can alter the design of the ship, you can change the materials being used in the ship. Like for example, if I put a simple example, when you look at a microwave oven, if any one of you have used a microwave oven, you may be knowing that you can put plastic and glass utensils in a microwave, but you are not supposed to put metallic utensils in a microwave. The reason is metals, they happens to reflect the microwaves. They happen to reflect microwaves, whereas plastic and glass allows the microwaves to pass through. The same logic is used in stealth, where you can change the material of the military hardware in such a way, instead of reflecting the radar waves, you become completely transparent to the radar waves, so that the radar is able to pass through rather getting reflected. So that basically will make your entire ship invisible to the surveillance system. Then apart from this, we can also use other technologies to dampen the noises, dampen the vibrations, and we can also use, in the case of fighter aircraft, we can often use speed, right, low observability and such, right? So these are some of the things. Like in the case of hypersonic missiles that we were previously talking about, altitude plays an important role. Altitude also plays an important role in keeping yourself hidden from surveillance technology. Normally, if you fly very low, then radars are normally not placed at low altitude. Radars are normally placed in order to have large area coverage. They are not placed at low altitudes. The reason is, when the radio waves are going to be thrown at a lower altitude, there would be a lot of false alarms. There would be a lot of false targets created. Like there would be a lot of buildings, there would be trees, there would be mountains. They may also be reflecting some of the radio waves, and in that case, the observer will not be able to figure out which one is really the enemy ship or the enemy vehicle. So for low altitude surveillance, we do not use radars, right? The human sight itself is considered as the best when it comes to low altitude. So imagine if there are fighter aircrafts, if there are missiles which are capable of flying at a low altitude, and that too at a high speed, they would definitely have more stealth features. So you can put this point under hypersonic missile as well, that hypersonic missile does not just give you the capability of attacking fast, but it also gives you the capability, if you can fly low, it can also make your system, your missiles, stealth or hidden from the surveillance technologies. I hope all of you understand this. So we already have, so basically this is the Project 17A, where we had an objective of making 7 stealth frigates. Now 17A is a follow-on project of Project 17. Project 17 was launched previously by the Indian Navy. It has been already successfully completed. It is basically a project to build Shivalik class stealth frigates. So Shivalik class, it's also a frigate, and for Project 17A is nothing but an extension or a follow-on project of the Project 17A. 17A is an extension of Project 17, right? This is also indigenously built. It contains warfare which involves anti-surface warfare, so it can go and attack on the surface. It has anti-air and anti-submarine warfare. The other 6 ships of the stealth frigate class that has been inducted under the under this project 17A is INS Himgiri, INS Taragiri, INS Udaygiri, INS Dunagiri, and INS Vindhyagiri. Right? These are the famous small ranges of Nilgiri itself. So this basically is named after the Nilgiri mountains. Right, guys? If you look at the nomenclature used in naval ships, they use a very typical kind of a nomenclature. It is somewhat easy for us to identify what nomenclatures have been used. Like if you notice various frigates, they are normally named after rivers or mountain ranges. If you talk about other ships like destroyers, they are normally named after cities. Right? So we'll see the next one. Right? So this is what we have. Then the ships are fitted with supersonic surface-to-surface missile system. We have the BrahMos system in India, which happens to be supersonic surface-to-surface. Then it is also equipped with medium-range surface-to-air missiles. The Akash system of India is basically having the medium-range surface-to-air capability. Then it is also having a 76 millimeter upgraded gun, right, and a combination of rapid fire close-in weapon systems. These are the weapon system that has been equipped in the INS Nilgiri. Then INS Surat. INS Surat is another important ship that has been inducted. Now you guys know Surat is a city. So like I said in just a conversation before, that mostly destroyers are named after cities. So one can easily understand, if Surat is a city, that means it is nothing but a destroyer type ship. So it's a stealth guided missile destroyer ship. That means it's a destroyer having stealth features and also capable of carrying a guided missile system. So there are three features about the INS Surat that can be easily understood from just by its first description. It's a destroyer class ship which is having stealth features and is also capable of carrying guided missiles. Right? Again, this has been indigenously developed under the Project 15B. So Project 15B is another project of the Indian Navy where we have tried to develop stealth class destroyer ships, stealth capable destroyer ships, and that includes INS Vishakhapatnam. You guys know it is a city. INS Marmugao is a city in Goa. Remember that. INS Imphal, and the fourth and the last ship of Project 15B is INS Surat. So INS Surat is the last ship of the Project 15B. It had an objective of making 4 stealth destroyer class ships. Then it has a size of around 7,000 to 7,400 tons. I hope all of you understand displacement means in relation with the Archimedes principle, 7,400 tons. It is equipped with surface to air missile. That means from surface can hit a target in air, anti-ship missiles, and also torpedoes. Torpedoes are technically meant to hit underwater targets. So you can hit a ship from underneath, you can hit a submarine. All these things a torpedo is capable of doing. It is meant for underwater targeting. And what makes Surat even more incredible, that it is Indian Navy's first AI enabled warship. It is the first AI enabled warship where we can use artificial intelligence based solutions to increase or to improve its operational efficiency. So imagine INS Surat at the center of the battlefield, using AI and devising its own strategies and enhancing our accuracies and enhancing our strategies to build better strategic plans. Right? So this is what we have under Project 15B and INS Surat. Now, like I said, Project 15B is also a follow-up project of Project 15A, under which India has built 3 other destroyers. That includes INS Kolkata, INS Kochi, and INS Chennai. Right? Again, all 3 of them are cities. Right? All 3 of them are cities. So this is what we have under Project 15A. Right? So I hope all of you have understood Project 15B, Project 15A, INS Surat, and then we have INS Vaghsheer. Now INS Vaghsheer, the name Vaghsheer basically means, it's a Marathi word for sandfish. Right? So what is exactly INS Vaghsheer? INS Vaghsheer is a submarine, guys. It is a diesel electric powered submarine. It is actually, by design, it is the Scorpion class inspired design of the French Navy. So French Navy has got a submarine called Scorpion. So based on the design of the Scorpion submarine, we have indigenized our INS Vaghsheer. So India and France had an agreement under Project 75. This Project 75 was planned way back in 1990s, but it was finally during Prime Minister Manmohan Singh's time when this Project 75 was executed. It was technically a technology transfer agreement from France, where France shared the designs of their own submarines, and Indian defense manufacturing companies, they started building those submarines. Now, under this Project 75, India planned to have 6 Scorpion class submarines, where 3 of them would be made in France. France or the French government will manufacture it, and the other 3 of them are going to be built in India. Now, INS Vaghsheer is the last installment of the entire Project 75. So this culminates the Project 75 as well. So you can understand, on the very same day, 15th of January 2025, 3 of our projects came to a successful end, right? Just to recall, Project 17A, right? This came to an end. Project 15B and the Project 75. All these 3 projects came to a successful end, where the last installments of these 3 projects were inducted or commissioned in the Indian Navy. I hope all of you understand this. So this is also an indigenously built submarines under a technology transfer agreement with France under the Project 75. I hope all of you understood. Let me just quickly tell you the names of all these 6 submarines. Now, the first submarine of this under Project 75 was called INS Kalvari. Kalvari is named after tiger shark. Tiger shark in Marathi is called Kalvari, and Kalvari is also the name of one of the fort of Shivaji, which was never captured by the Britishers, right? So Kalvari is a quite popular name in Marathi, and in fact all the other ships or submarines in this class are named after fishes in Marathi. So Kalvari, then second is INS Khanderi, third is INS Karanj, fourth, now these 3 are the ones that were built by France, right, and inducted to us, right? Then comes the 3 which are built in India by Indian manufacturers. This includes INS Vela, INS Vaghsheer and INS Vaghsheer. Right, Vaghsheer is the last one to be inducted with the Indian Navy, and this also successfully culminates Project 75. Now, what is interesting about these submarines, I have previously talked about how important it is for us to remain hidden. When it comes to a naval battlefield. What is the interesting thing is, the Scorpion class or the Kalvari class, we are calling it the Kalvari class, not the Scorpion class. The Kalvari class happens to be one of the world's most silent and versatile diesel electric submarines, right? What is interesting about them is that their propulsion system is air independent. We don't have to carry oxygen separately. The propulsion system itself has oxidizers mixed in it, which can give a very high capability of smooth burning of the fuel, does not cause a lot of suffocation to the naval officers in the submarine, and it can remain for a longer period underwater with the help of the air independent propulsion system. Now, this particular submarine is fitted with anti-surface warfare and anti-submarine warfare. It is also capable of surveillance and intelligence gathering. I hope you understand submarines play a very important strategic role as well, where they can remain underwater hidden so that they can easily monitor the movement and the activities around any strategically important waters, right? Then it is also capable of helping in underwater mining and mining laying off for Navy. So for laying out mines underwater, and also it is the 6th and the final submarine under Project 75, not the Project 17, Project 75, right? So this is what we have under the INS Vaghsheer. Now, moving on, the next topic is the discovery of semi-Dirac fermions. Now, this is a topic related to quantum physics, or you can say standard atomic model. Now, before I talk about the semi-Dirac fermions, let me give you a disclaimer first. Now, guys, when it comes to physics, Like we study history, we know that history also has eras. There was an era of history which we considered as ancient era of history, where we talked about the Bronze Age, Harappans. Then there's an era of history which is treated as medieval history. And then came the modern history era, which started with the onset of the Britishers, right? Depending on which book you are referring to, right? So, like we have differences of eras in history, similarly, science, the current discipline of science itself, has two eras. One is the classical physics or the old physics, and then we have the new physics or modern physics, right? It is believed that the year 1900 became the dividing line between old and new physics. In old physics, we used to normally observe large and slow moving objects. Like we used to observe the movement of planets. They may be moving at few thousand kilometers an hour, but they are still slow. So we used to consider the movement of planets, gravity. We used to consider electric current. We used to consider forces that are easily tangible, that are easily, observable, friction and such forces. We used to consider optics. These were the disciplines that were popular in the old physics era, or you can say the classical physics era. After 1900, or especially with Max Planck's work on photons, Max Planck's work on particles of energy, we entered into the modern era of physics, which is called the new physics or the modern physics. Now, what is fascinating is that in the world of new physics, our traditional laws of physics don't work in the same way. Like when you talk about Earth and Moon, it is easy to observe gravitational pull. It is easy to calculate gravitational pull between large objects. You can even calculate gravitational pull between your mass, your body and planet Earth, your body and Moon. You can even launch satellites up in space with the help of that connotation. You can easily do everything when it comes to satellite launching with the help of Newton's gravity. But don't you think even inside an atom, there would be gravitational force between electrons and the nucleus? They also have mass. So if mass is the one that manifests gravity, then electrons should also have some gravity influencing over the nucleus. Now when it comes to such small particles inside an atom, it becomes very difficult for us to use the same laws. So the same laws of classical physics does not apply in the same exact way when you're dealing with extremely small matter. Just like, when I say extremely small matter, it means subatomic observation, matter smaller than a single atom. It is almost impossible for us to observe the universe of subatomic particles by using the same classical physics. So every law of physics has to be remodeled. Every law of physics has to be thought. Rethinking has to be put in. And what is more interesting is that there are a lot of phenomena inside an atom at subatomic level, at extremely small level, which we have not been able to understand fully. We haven't been able to understand a lot of phenomena that occur inside an atom. So it is still a science which is in a very nascent stage. We know something, but we do not know a lot of more things. There are a lot more things to be learned. So when it comes to the idea of matter, when it comes to an idea of atoms, still this question in the world of new physics has not been answered, that what is an atom really made up of. It is quite a surprise, guys. We have been learning so far that atoms are made up of electron, proton, neutrons, but in the world of modern physics, it is still not 100% sure. We are still not 100% sure how many particles could be there inside an atom at different instances. So in 1950s, some scientists proposed, the scientists of that time, they proposed a new way of looking at matter, a new way of looking at atoms. And they proposed the standard model of atom, the standard model for particles, which basically says that every matter or every atom is typically made up of two types of particles. It could be made up of particles known as fermions. It is made up of particles known as fermions. I'll write them here, fermions, and the particles known as bosons. By the way, guys, fermions are named after Enrico Fermi. I'll write it again so that if you guys are making notes, then you should be able to understand my handwriting here. Just one second. So we have fermions, that is one type of particle, and the other type of particle is bosons. And we have got bosons. By the way, fermions are named after an Italian scientist named Enrico Fermi, and bosons are named after Satyendranath Bose, right? So these are the two types of particles that are found in an atom according to the modern physics, according to the standard model of elementary particle or standard model for atoms, right? And these fermions and bosons are the ones that are further divided. Like fermions are further divided into two different particles called leptons and quarks, and bosons are further divided into two types of particles called gauge and scalar. Gauge and scalar. There are two types of bosons. So gauge bosons, scalar bosons are two different types of bosons, and fermions are divided into quarks and leptons. So likewise, we have different types of particles. Now guys, we don't have to dive very deep here. We just have to acknowledge a fact that it is still a work in progress. You'll be surprised to know that after discovering so many particles, these are the particles that we have discovered, by the way, inside an atom and different occasions. But still this model is incomplete. That means there is still a hope that there could be many more particles that can be discovered. The number can go as high as 32, right? So there is a possibility that many more particles could be found inside an atom. So the question is where we have to draw the line for UPSC exam, where we have to draw the line for civil service exams, what we can expect at max could be asked. So here I'll try to narrow down the entire discussion and talk about just a recent discovery. There is a recent discovery where the researchers have been able to find a particle known as semi-Dirac fermion. They have been able to find a particle. In fact, it is not even an actual particle. It is not even an actual particle. It is simply a kind of a quasi-particle. A quasi-particle means it's not really a particle. It's nothing but a collection of few electrons. It is nothing but a collection of few electrons, and when these electrons are collected together, they start behaving, they start mimicking a nature of a single particle, and that single particle is called semi-Dirac fermions. So I have just now told you that fermions are a type of particle within the atoms. You may find atoms made up of fermion type particles. In fact, you would definitely be able to recognize few fermion particles if I note down for you. Electrons, you can see under the lepton category, electrons, it is a type of fermion particle. You can also see protons, right? Okay, I'm sorry, that particular basically protons is a type of a baryon type particle that comes under quarks combining into each other. So electron, protons, neutrons, they all are fermion type particles you can consider, right? It has not been shown here, but you can write it that they all are type of fermion particles. So here you can see few recognizable names. But when I talk about the recent discovery, this recent discovery was made where they have found a certain particle or collection of particles together, which is called as quasi-Dirac fermions. Now semi-Dirac fermions. Now what exactly is a semi-Dirac fermion? A semi-Dirac fermion is named after the Paul Dirac's equation. Now Paul Dirac, he proposed that there could be particles that may be following. He was the person who talked about antimatter for the first time. He came up with an equation, and through that equation he realized that there could be two types of matter. One is the regular matter that we know, and there should be an antimatter to it. So regular matter means like electrons, and the antimatter to electron is called positron, which is same in terms of mass, but in terms of charge it is opposite. And if electron and positron ideally should meet, they may destroy each other and convert into energy. So a particle and antiparticle, or matter and antimatter, their derivation starts from the Dirac's equation, Paul Dirac's equation. So basically, semi-Dirac fermions are basically particles that tends to show a similar nature, partly a similar nature of Paul Dirac's equation, and also contains mass just like other fermions. And this particular particle has been observed recently It has been observed in the Xerces, zirconium silicon sulfide crystals. So scientists took the zirconium silicon sulfide crystals. They first kept it at a very low temperature, near 0 Kelvin, near absolute zero, and then they passed a ray of infrared to see how the particles inside this matter is behaving. So they took this particular crystal, zirconium silicon sulfide crystals, they super freezed it to a temperature close to 0 Kelvin, to a temperature close to minus 273 degrees Celsius, and then passed a ray of infrared to observe how the particles of this crystal are behaving. And then they realized that these particles have been behaving in a very different way, where they partly behave as a object having mass. Fermions are those particles that carry masses. Fermions are those particles that carry mass into an atom. So whatever my body, whatever my mass is, it's technically the total weight of all the fermions in my body. What are bosons, guys? Bosons are the particles that carry forces, right? So they carry forces. So we have gluon, photon, Z boson and W boson. These are the particles that carry force. So we normally have three types of fundamental forces defined under the standard atomic model. We call it the strong nuclear force, weak nuclear force, and electromagnetic force, right? So these particles, fermions and bosons, they happen to be following certain certain properties. Like fermions, they carry mass into the atom. So more fermions means more mass, and bosons carry forces into an atom. So based on the types of boson particles, the forces into an atom may be balanced or imbalanced. We'll see, depending on the types of particles or the number of particles. So when you look at this zirconium silicon sulfide, the scientists, they first supercooled the zirconium silicon sulfide to minus 273 degrees Celsius, and then they passed a thin ray of infrared and saw the behavior of the crystals. And what they recognized, what they observed in the behavior of the particles was very interesting, because they found that sometimes these particles were behaving like fermions, where they were showing mass, and sometimes they were behaving as massless, right? So sometimes they had mass and sometimes they became massless. So when partly they were showing as mass and partly they were showing massless, the scientists further studied and found out that when they are moving in certain direction, when they are made to move in a certain direction, they happen to show mass, they happen to manifest mass. And the moment when they are made to travel in the opposite direction, they become massless. That means they are trying to behave as particles of mass and particles without mass, just by changing the direction, just by changing their motion. And that nature, because if it would have shown mass throughout the time, then it means it is typically a fermion particle, it is manifesting mass. If it would have shown no mass throughout the time, then it could have been boson, it could have been other particle other than fermions, right? It could be a matter or an antimatter, most likely a particle derived from collision of matter and antimatter, which is having zero mass but only energy. But because it is showing mass, and that too partly, it has been given a status of semi-Dirac fermions, right? Semi-Dirac fermions, and that makes this semi-Dirac fermions, they have mass when they are moving in one particular direction, but they are massless when they are moving in another direction. Now many of you may be thinking that how it is possible for something to have mass and then just by changing its direction becomes massless. Guys, I would like to tell you just one thing. In the world of quantum physics, it is just how it happens. This is how it happens. There are a lot of things in quantum physics that we haven't been able to comprehend, right? The working of quantum computing, there are a lot of things around us that we haven't been able to comprehend. It is just a work in progress. We are still at that state of time where a lot more research in the world of quantum physics is yet to happen. A lot many unanswered questions are there, and to be honest, we know very little about why these things are occurring. We have only made observations, but to answer why these things are occurring, it is still a work in progress. I believe all of you guys are able to understand. So how did we discover these particles? So we discovered when the Xerces, the zirconium silicon sulfide, was cooled to a near absolute zero temperature and then subjected to a magnetic field 2.5 lakhs times stronger than the Earth, and then by simply exposing an infrared ray, we observed the presence of semi-Dirac fermion particles, right? What is the significance of this discovery? This discovery holds an important significance in learning the behavior of matter, how the matter would have originated, how the first matter would have got created, and how the possibilities of different types of particles are there. And then on top of that, we can actually use this discovery in the world of quantum computing. By understanding how these particles are behaving, we may be able to control their, if we can control their behavior, we may be able to use it in the world of quantum computing, quantum physics, further research in the area of particle and quantum physics, right? So if UPSC would want to ask a question, there is a high chance that UPSC may ask about the discovery, and they may simply ask you, how is this discovery beneficial to us? What opportunities can be created by this particular discovery, right? That's it. I don't think there is a possibility of asking even deeper question from here. But please make sure that you read about CERN laboratory, right? This is the famous, the biggest physics laboratory in the world. It is with the European Union. In English, we call it that European Center for Nuclear Research. European Center for Nuclear Research. In French, it has a different name. It's actually a French word. It's a French acronym. So its actual name is different, but in English, it's called, European Center for Nuclear Research. Please do read about it. When you read the Compass article, which is going to be tagged along with this video, you will definitely have a lot more things to read there, right? Now, next is the cabinet has recently given an approval for the third launch pad at Sriharikota. Now, what is the launch pad? Launch pad is basically what you see on the screen. This entire thing is technically the launch pad. It is the location from where the satellite launch vehicles take off, right, or lift off. We call them simply launch pads. So the cabinet has recently given an approval for the third launch pad at Sriharikota. So when you look at the Satish Dhawan space station, which is our name of the space station at Sriharikota, we already have two launch pads. The first launch pad is used for PSLV, Polar Satellite Launch Vehicle. It is the pride of our country, the most successful rocket of India so far. The first launch pad is used for this, and it is also used for the smaller rocket called SSLV, Small Satellite Launch Vehicle. So as of now, we are using it for Small Satellite Launch Vehicle also. I hope you all know that there is another space station planned, which is going to be built at Tamil Nadu in a place called Kulasekharpattinam, right? Which is going to be exclusively built for SSLV, right? But right now, as of now, we use the launch pad 1 for PSLV and SSLV. Then we also have the second launch pad, which is used for GSLV. The GSLV, which is a bigger launch vehicle, it's called the Geosynchronous Launch Vehicle, Satellite Launch Vehicle. Geosynchronous Satellite Launch Vehicle. We use the second launch vehicle for GSLV, and we also use the second launch vehicle as a standby for PSLV. So if the first primary launch vehicle is not working, we can use the second launch pad for PSLV as well. But it works as a standby. Now ISRO is planning for the third launch pad. What will be the function of the third launch pad? Its function is going to be to work as a launch pad for the next generation launch vehicle. NGLV is expected to be the next rocket in the entire range of rockets of ISRO. Right now, the maximum capability that we have is somewhere around 8 to 10 tons that we can lift as high as the lower Earth orbit. But with the help of this rocket, the GSLV is the biggest rocket that we have right now, right? GSLV LVM-3 is the biggest rocket that we have, it is the same rocket that has been developed, that was used to put Chandrayaan 2 and 3, and also it is the same rocket that will be used for the first Gaganyaan mission. But this rocket is good, but not good enough for the future plans of India, where we have an objective of setting up a space station, where we have an objective of putting humans to moon. We need a bigger launch vehicle, guys, and for that we need a launch vehicle at least 30 tons, 30,000 kilograms of payload capacity. So that is what NGLV is expected to be. So if NGLV wants to become a reality, it has to have a bigger launching pad. So the idea of having the third launching pad is basically to support the next generation launch vehicle, and it should also act as a standby for the LVM-3 which is already there. So we already have the second launch pad which is used for launching GSLV, and the third launch pad will behave as a standby for the GSLV rockets, right? Which is the second, which ideally use the second launch, second launch pad. And this is going to be located next to the second launch pad only. It is going to be built at the place of Sriharikota, and it is, the main objective is to enhance, to maximize the use of the current infrastructure, right? The first and second launch pad I have just now told you. First launch pad is used for PSLV and SSLV, and the second launch pad is used for GSLV, right? This is what we have, and you understand the significance, you understand the importance of having the third launch pad, and also keep a note of the next generation launch vehicle India is planning, which is going to be bigger and would be capable of carrying an even higher payload, right? Up to 30 tons or 30,000 kilograms in the space, right? So what is going to be the significance? What is going to be the significance of this? So please ignore this particular so what is going to be the significance? The future Indian human spaceflight mission, if you want to make it a success, like the planned Gaganyaan mission is going to be launched by GSLV LVM-3, but if you want to make a successful attempt of bigger bigger human spaceflight programs, then we need a bigger launch vehicle which can carry higher or bigger payloads. Bharatiya Antariksh Station by 2035, and the Indian crewed lunar landing by 2040, which is also one of our objective. So this is clear that without having a bigger launch pad, it may not be possible for us to launch and to send probes or to send humans or sophisticated missions this far. I hope all of you understand. Now the next topic of our discussion is the new definition for obesity, right? Obesity is already a problem in urban India. You guys may be aware that our most of our health standards have already shown that Indians are showing high signs of obesity related illnesses, right? So let's talk about it. So this has been related to a study that has been published in the Lancet journal, and the Lancet Commission has also come up with some reports on obesity and how the definition of obesity have changed, and typically for Indians it has been changed even further, right? So guys, when you talk about obesity, the standard method that we use is body mass index. Body mass index is nothing but the weight of the individual in kilograms, right? Weight of the individual in kilograms. This is what the body mass index, and divide by the square of height. Divide by the square of height. So you write the body mass index and divide by the square of height. Whatever the height is, put the square of the height. This is called body mass index. Now, if you consider the body mass index, we have a global cutoff for BMIs to check if the person is underweight, overweight, normal, or obese. If the BMI comes out to be 18.5, the person is considered to be underweight. If the BMI comes out to be 18.5 to 24.9, it is considered to be normal. And if it comes out to be 25 to 29.9, then it's considered to be overweight. And if it goes over 30, then it's considered to be obese, right? Then it's considered to be obese. I hope all of you understand. So a simple parameter we follow for the global definition we used to follow for the global definition for obesity. Now, this definition is having a lot of problems associated with Indians. In India, there are a lot of people who have been diagnosed with BMI levels less than 30, but still they show high level of obesity related illnesses. Remember guys, there are 3-4 illnesses which are directly related to obesity. Insulin sensitivity, insulin resistivity, right? Pre-diabetes, diabetes, in fact, fatty liver disease, hypertension, cardiovascular disorders, and muscular degeneration, skeletal degeneration are a lot of diseases which are related to obesity. So in India, it has been quite extensively found that even if an average Indian may have a BMI less than 30, still they often show obesity related illnesses. And that's why even before this new definition came in India, obesity is normally treated from BMI 25 onwards. obesity in India is normally treated from BMI 25 onwards itself, according to the recommendation by ICMR, that in India BMI of 25 onwards is related to obesity, and obesity related diseases are going to be more common in such people. I hope all of you understand. Guys, actually the reason why we have this, because when you look at the types of fats in fats, there are technically two types of fats that we have in the body. One is called the subcutaneous fat. Subcutaneous fat, cutaneous. So we have got something called subcutaneous fat, and the other one is visceral fat. Guys, this subcutaneous fat is basically the fatty layer under the skin. So under your skin, we have got a layer of fat, and that fatty layer basically is called the subcutaneous fat. If you touch your skin and try to grab between your fingers, what you can actually feel, if I twist my fingers like this, I can actually feel the subcutaneous fat in my fingers. I can actually feel the subcutaneous fat here, right? So this is basically the subcutaneous fat. This fat is not considered to be dangerous. This is the normal body fat only, and this is not supposed to be dangerous to us, right? A higher level of subcutaneous fat is not that dangerous, right? It is not related to fat related illnesses. But visceral fat is basically the layer of fat over organs. So when the fat deposition starts occurring over organs, and that too important organs like liver, kidneys and such, then this visceral fat becomes a challenge. And it is the visceral fat that is the problem. So in India, you may have a BMI less than 30, but if your visceral fat content is high, you may still have obesity related illnesses. I hope you guys are able to understand. So one can easily understand that India needs a separate definition or a much broader definition for fat or obesity. I hope all of you understand. So we have found Indians showing signs of hypertension, showing signs of cardiovascular disorders, showing signs of skeletal degeneration and such, because even when the BMIs were significantly lower than average global cutoffs. I hope all of you understand. So that's why in India the BMI standards has already been revised and kept below 25. If the BMI is more than 25, it is treated as obese in India. But remember guys, BMI is not always enough. We have to have a better scanning of the deposition of visceral fat in the body. There is a scan called DEXA scan. There is a scan called DEXA scan that can actually be done for seeing or observing the distribution of visceral fat in the body. DEXA scan we call it. I hope all of you guys have been able to understand. Now defining obesity, so we all understand. Now another interesting term here is, so clinical obesity is basically the obesity which has been clinically declared to be a chronic illness. So now clinical obesity has been declared as a chronic illness. It has been declared now a chronic illness. So obesity is now treated as an illness, and this, because it's an illness, you need a physician to diagnose it. You can't use your own self experience. You can't use your own intuition to diagnose whether you are chronically ill with clinical obesity or not. You need to go to a physician, and a physician is supposed to consider certain parameters like height, weight, waist circumference, muscle mass, and functioning of various organs. Like I said, visceral fat is the one that affects the functioning of the organs, and the normal symptoms that has to be observed is basically the breathlessness, wheezing, sleep apnea, high triglyceride levels, metabolic dysfunctions, non-alcoholic fatty liver disease. That means fatty liver even when a person has not been consuming alcohol, changes in the reproductive system, heart failure, chronic fatigue, knee and joint pain, physical activity of the individuals, inability of doing any physical activity. These are the symptoms related to clinical obesity. And guys, there is a new term that has been introduced in place of overweight. Now we are using a word preclinical obesity. So if a person has been overweight for a major time, it is considered to be preclinical obesity. So this is the new change that has happened by replacing the word overweight with preclinical obesity, right? Where a person has excess body fat but no associated ongoing illnesses, but this is preclinical obesity. That means if it goes on increasing, if the body fat goes on increasing, it will be diagnosed as chronic illness later. The Lancet Commission suggests looking at any two of the following four parameters for evaluating the body size. So BMI, waist circumference, waist to hip ratio, and waist to height ratio is the one that has to be considered in order to observe the body size of an individual, right? Fat content, I told you already, DEXA scan is one method of knowing the fat content in the body. And the Indian guidelines for obesity is, we normally do not use, the categories of preclinical or clinical. We basically divide obesity under stage 1 and stage 2, where technically stage 1 is preclinical and stage 2 is clinical only. So stage 1 is where the BMI is more than 23, right? But and the waist circumference and waist to height ratio is optional for this group, but do not have symptoms that show limitations in day-to-day activity. So the BMI is high, but they do not show symptoms of limitation in the day-to-day activity. It is preclinical. And in stage 2 obesity, where the BMI is high and a person is suffering from obesity associated limitations, right? I hope all of you understand this. This is what is the Indian definition for obesity now, right? I hope you understand. UPSC can straight away ask questions related to BMI. They can straight away ask questions related to preclinical and clinical obesity. They can also ask questions related to Indian standards or what is the right parameters for obesity in India. So remember, now the BMI has been further reduced to 23, which was earlier 25. And now a person having BMI more than 23 is considered to be obese. I believe all of you guys are able to understand. This is what we have under Indian definition for obesity. Now the next topic of our discussion is antivenoms. This has been the news in the Hindu newspaper, right? There has been a recent study which has found out that the supply of antivenoms, right? Snake bites have been very common in India, and supply of antivenoms have been very less in the country, right? So let's see. And there's a subsequent news which talks about creation of new types of anti-venom drugs, right? Anti-venom therapies, right? So let's talk about it. It's an interesting topic. Let's see. So first of all, it's a small topic. I'll quickly finish it. You should be able to understand. So remember, India is the global capital when it comes to snake bites related death. It is quite a surprise, guys, that in India, in the year 2024 it alone, there have been 58,000 deaths caused due to snake bites in the country. 58,000 deaths have happened because of snake bites. 58,000. And in India, there are approximately 300 species of snakes, out of which nearly 50 of them are venomous. Nearly 50 of them are venomous snakes. And within these 50, there are 4 of them which happens to be highly poisonous, guys. Their venom is very toxic. All of you must be aware, we have the king cobra, whose venom is supposed to be one of the most venomous, one of the most toxic. Then we have common krait. You should be knowing about these snakes, guys. Third is Russell viper. And the fourth is saw-scaled viper. Saw-scaled viper. These 4 are the very venomous and commonly found snakes are responsible for snake related deaths. Now the antidote or the anti-venom that we normally use is called PVA. It's called polyvenomous antigen or polyvenomous antivenom, right? Sorry, polyvalent. I'm sorry, guys. It's called polyvalent antivenom, right? Polyvalent antivenom. So polyvalent antivenom normally works against these 4 snakes. Against these 4 snakes, we use a polyvalent antivenom. These 4 snakes, against this we have the PVA functioning. So PVA functions, or PVA actively responds against these 4 venomous snakes. But you can understand, if you understand the process how we produce the snake antivenoms traditionally, you will understand the side effects caused by it. So guys, mostly these antivenom, this PVA is extracted from horses. This has been the technique used since the early 19th century, where what we do, we take the venom out of the venomous snakes, we milk the venom out of the snakes, and then we give small doses of this venom to horses. The horses' antigens, antibodies, they get activated. They start producing antibodies the moment when they come across to this venom. And once they start producing antibodies, we'll observe them for some time, and once they get back to their full health, we take out the blood sample, because now the blood contains the antibodies against the venom, and then that blood is further cultured, from where we take out the PVA, right? So we basically take these 4 venomous snakes, expose them to to a horse in a slow manner, and then eventually wait for the antibodies to be created. So this is how these antibodies are created, and then they are used for treating people who have been bitten by snakes, right? So this has been the method, but one can easily understand that there will of course be a lot of side effects here. The first side effect is very clear, that this particular medicine involves causing pain to another animal. Then when you are extracting this particular antivenom from an animal itself, when it is introduced in the human body, there may be certain proteins that our body may not recognize, and we may start creating antibodies against those proteins, right? So it may further weaken the immune system of the person, and on top of that, it may cause a lot of side effects as well in the person. So it is quite obvious that these antivenoms, even if they have been developed for the past more than 150 years, still they are not treated to be the best possible solution. So this is where recombinant DNA technique, a very popular genetic engineering tool, is being now used to create synthetic antivenom or synthetic antivenom drugs. So what they do here, they see, and one more thing, these PVAs work only for these 4 venomous snakes. What if a person is bitten by other than these 4 snakes? There are still 46 other snakes in the country which are poisonous, but they are not that common, but they are still there. So if a person is bitten by those 46, how are we going to save that person? So this again becomes a question which the PVA is not very capable of handling. So scientists have now come up with a new synthetic antivenoms which have been developed by using artificial intelligence and recombinant DNA technique. It's a joint study by the scientists of UK, Canada and India, and this basically involves using recombinant DNA technique. So recombinant DNA technique is a technique where you take a fragment of the DNA against which you want the immune response to be triggered, and then eventually, so you take out that particular gene of interest, that particular fragment of the DNA, which is the antigen here, and then you put that antigen into a carrier. The carrier is mostly a bacteria. The carrier is mostly a bacteria. So we use some genetic engineering tool where we add that particular gene, that venomous gene, into a bacteria, and then this bacteria is expected to respond against this gene, and then eventually start making copies of this gene, right? And as this bacteria makes copies of this particular gene, this bacteria, which has been inculcated with the gene of interest, this bacteria has now been modified, and now this bacteria carry that specific gene against a certain venom, against a certain antigen. So now if a person has been bitten by a specific kind of a venom, you can easily engineer a new bacteria which may have the antigens produced, or which may have the antibodies produced against that particular venom, and you can inject those antibodies into the person, and the person can be saved. And because there is no derivation coming from the animals, there would be no side effects. It will not be carrying any other gene other than the antibodies that are supposed to be secreted. So by using this recombinant DNA technique, we can make the entire system a little more, less painful for horses, less painful for animals, and much more beneficial for humans, because now we can actually create anti-venom drugs which are specific to a certain venom, will not carry other antibodies, so the person will not show much side effects, and a person will also be able to use a smaller dosage to prevent the damages caused by venomous snake bites. I hope you can understand, and this basically makes the entire system far better than what we have been dealing with today. But remember, this is still in a very nascent stage. It is just a preliminary study in this area that has happened. It will still take a long time for actually introducing recombinant DNA technology based antivenoms. So the research from Denmark and UK and USA, led by the 2024 Nobel laureate David Baker, reported designing synthetic antivenom successfully using artificial intelligence. The significance is that its effectiveness is greater. It can be made available because we don't have to wait for the venom to first go into the horse and then eventually produce antibodies. So we don't have to wait. Availability can be made straight away, and we are using computer designed proteins that can optimize the function of the antibodies in different clinical settings. Like region specific antivenoms can be created, and by mapping the toxins composition, scientists are attempting to create tailored antivenoms for more precise treatment as well. So these are the possibilities that can be developed, that can be created with the help of recombinant DNA or rDNA technology based antivenoms. So this is the part what UPSC can ask. They can ask a question related to snake bite related deaths in India, and they can also ask questions related to rDNA technology and its applications. You can expect a question like this in the prelims easily. Then guys, the last topic of our discussion is related to human papilloma virus or cervical cancer. I hope you all understand that cervical cancer is the second most widely found cancer among Indian women, and it is said that most of the cancer cases that we have around the world, cervical cancer is one of the most common types of cancer. Almost 20% of the global cervical cancer patients are found in India. Cervix is basically, it is the small opening that connects the vaginal pathway with the uterus in case of a female reproductive system, right? So when you look at the female reproductive system, you have the uterus where the baby is kept when the baby is growing, and we have the cervix which eventually opens up when the mother is about to deliver the baby, right? So the cervix needs to open up. So cervix is basically that small pathway, and it is the human papilloma virus. It's a virus which is a double-stranded DNA virus. That means the nucleic acid present in this virus is not RNA, it is DNA, just like the human DNA, double-stranded. And this particular virus is so infectious, it can infect both men and women, and almost 5% of all cancers that are happening in the world, they are derived from human papilloma virus related cancer. A very big number, guys. 5% of all cancer cases in the world are human papilloma related virus, and this virus can mostly transmit sexually or through intimate skin to skin contact, right? And mostly, guys, this virus, our natural immune system is capable of protecting us, but sometime if this virus is carrying a new strain, if there is a new complex strain, then that particular complex strain of virus can trigger cancer. Now cancer is the cervix is the most common cancer in females of the world, right? Most common type of cancer in the females of the world is cervix, but in India the most common female cancer is breast cancer, second is cervix cancer, right? And in fact even the male genitalia is vulnerable to this type of cancer. So this cancer is not just prone or found in females, but it can also be transferred to male genitalia as well. Remember this. And unfortunately, so far there is no treatment to HPV infections. We all understand most of the HPV can easily be cured by the natural immune system, but once it develops into a cancer, then unfortunately there is no treatment. We have to undertake the treatment that is available for cancer, and it does not show a very high success rate. But thankfully now we have got the HPV vaccines. We have got the human papilloma virus vaccines, which are found to be very effective in preventing the onset of HPV induced cancer. Now this HPV can actually induce cancer in all these body organs. It can cause the vulvar cancer, it can cause the oropharyngeal cancer, cervical cancer, anal cancer, genital penile cancer. All these kind of possibilities are there in the case of human papilloma virus. Now what is the status of the human papilloma virus vaccine in India? So the Serum Institute of India has already been able to develop a vaccine. It's called Servavac, right? It is a quadrivalent HPV vaccine. That means quadrivalent means it protects you against 4 different strains of HPV virus. There are 4 different strains of HPV virus against which this vaccine is found to be effective. And if a person wants to prevent this vaccine, this particular cancer to happen, then we also have the National Technical Advisory Group for Immunization and NTAGI, which has already suggested, which have already recommended to induct HPV vaccines for girls within the age of 9 to 14 years in the country under the National Immunization Program. So it is already a recommendation, and Government of India is already thinking of including HPV vaccines for females from the age of 9 to 14 years under the National Immunization Program. But guys, for those who has not been vaccinated with this HPV vaccine, they should definitely go for regular cervical cancer screening. We have two kind of tests here. One is called pap smear and HPV test, which is often used to check the chances of this HPV induced cancer. Remember, HPV is responsible for 99.7% of cervical cancers worldwide. India is having the largest number of cervical cancers in the world, which is approximately 20%. And cervical cancer is the second most common cancer among Indian women. I hope all of you understand, and you also understand what is the name of the vaccine. So remember the name of the vaccine. UPSC can ask this straight away. And also remember what is the current statistics related to cervical cancer. It is the second most common cancer among Indian women. And this is basically, guys, includes the entire discussion on the subject of current affairs in this week, right? So guys, please do read about it. It was a long discussion because I had covered so many topics. And just to tell you one thing, there was also one topic of quantum cryptography which I couldn't inculcate in this discussion, so I'll be putting it on in the next discussion that we are going to have next week, right? So till that time, we'll meet. All the best, guys, and we'll be meeting next week now. Thank you.